This is DANL100 Programming for Data Analytics. Chapter 10 Simple Matrix Manipulations. Agenda. In this short video, I'll discuss the following topics. Topic number 1. We combine column to a matrix. And we'll discuss a few functions. Matrix, as a matrix, is matrix, number of the rows, and number of the columns. Topic number 2, matrix manipulation, plus, minus, two types of multiplications, element-wise matrix multiplications and a true matrix multiplications. Topic number 3, a few applications. Topic number 1, how to convert a matrix. Topic number 1, how to convert a vector or how to construct a matrix. Okay, so let's assume, so dot C10. So this is chapter 10. Okay, what is a matrix? Second one is row, column versus matrix. And as I mentioned before, we have three types of data. So usually we have scalar, so like present value equals 100. Okay, so this is we call the scalar. We only have one data point. Okay, the second one is called vector. So x equals 1 to 10. So is vector. Okay, it's true, is matrix, then it's false. Okay, so we have a vector called x from 1 to up to 10. Okay, and we can easily suppose I call A matrix x 5 2. Okay, we know that x has a value 1 2 3 4 up to 10. We use this 10 value, we form a matrix 5 by 2. 5, the first number is number of the row, the second number is number of the columns. Okay, and so actually when we use A equal this one, A equal matrix x comma 5 comma 2, we have by row equals false. So actually we have this assumption. Okay, so this indicates the default value for by rows is false. Okay, so we have 10 value. We fill in the first column, the second column, and continue this way if we have multiple columns. Okay, so let's look at the by row equals true. So let's call it A2. So by row equals true. So this is A2. Okay, so by row equals false, we fill in the first column and the second column. By row is true, we fill in the first row, second row, third row, and continue this way. Okay, just imagine, suppose we have classroom. Okay, we have many students waiting outside. Okay, if by the column student enter the classroom to fill in first column, second column, continue this way. So this is by row equals false. Okay, so if they fill in the first row, then second row, then third row is called by row is true. Okay, so this is A. Okay, so let's look at is matrix A. The answer is true. Okay, so this is, we can like column names. A, so let's use some C. So let's column 1 and column 2. So this is A. Okay, so we have column 1, we have column 2. So this is we convert a matrix, a column to a matrix. Okay. And so let's look at combine the two. Okay, 2. And suppose x equals 1 to 10, y equals no 10. So x, y, we have 2 columns. Okay, so this is we call the b equals c bind. So x and y. Okay, so this is b. Okay, is matrix. And so actually b, we use c bind. We can combine 2 columns as a matrix. Okay, and also be careful because when the matrix we have only one types of data. Okay, suppose we combine and we add haha. Okay, then everything becomes a string variables. Okay, when we form a matrix, be aware of the recycling rule. Okay, so let's look at x equals, we still use 1 to 10, y equals a random number from a normal distribution. Okay, so x has 10 value, y has 5 value. Okay, so if we form called a c bind and x and y, because y only has 5 variable. Okay, so this 5 variable recycle. Okay, so 0.51, 0.51, 0.4299, 0.4299. Okay, so if we have 10, you have 10, x, 5y, y will recycle twice. Okay, so let's look at what happens if y only has 3 value. Okay, and now we have different y. Okay, 2.50, 0.91, 0.07, you see 2.5 and 2.5, 2.5 and 2.5. Okay, because y only has 3 value and x has 10, then the first number recycle 1, 2, 3, 4 times. The other value recycle 3 times. Okay, honestly speaking, this is not a good property. Just be careful, there are some recycling rules. We just form a matrix called A. So we type A, then we can see its value. So this is first column and this is second column. Okay, for the matrix, and so if we want, we can also rename this column name. Suppose column names and A, then we can call data 1 and data 2. Okay, and before is x and y, now we call data 1, data 2. Okay, so if you want to retrieve part of the data set, and for the column, we can use A. For example, we are interested in the first column, so we can use A, and nothing on the left hand side of the comma, and 1. Okay, so if we're interested in the second column, we can use this one. Okay, suppose we're interested 2 to 3, so this is row 2, row 3, and the second one. Okay, then we can use A 2 to 3, comma, and 2. Okay, 2 to 3, comma, 2. So this is how to give the matrix as a name, and also give we can choose partial part of a matrix. Topic number 2. So let's look at the simple matrix manipulation. So basic basic idea is we are going to discuss the plus, minus, and element-wise multiplication and division element. Multiplication. So plus minus element-wise multiplication and element-wise division. Okay, so this is, and so let's generate a simple one. Okay, A equals, okay, matrix, and from 1 to 10 and 5, 2. Okay, we generate a very simple matrix. Okay, so A from 1 to 10, and we have 10 value, and we have 5 rows, 2 columns. So this is, we fill the 5 by 2 matrix according to column. Okay, dimension A is 5 by 2. So another way to look at it is number of the row A. So number of the row is 5, and number of the column will be 2. Okay, number of the row and number of the column. Okay, if we can use we assign this value to an output. Suppose we assign called n dimension of A. So n has 2 values. Okay, n1 will be a number of the row, and n2 will be a number of the columns. Okay, okay, so this is a value. So let's make a b. So b equals 2 times a. Okay, so this is a, so this is b. Okay, so let's look at plus, minus, and element-wise multiplication and element-wise division. Okay, and so basic idea is for all these 4 operations, so addition, subtraction, and element-wise multiplication, and element-wise division, A plus B, or matrix A plus matrix B, they should have same dimension. Okay, in this case, A and B. So dimension of A is 5 by 2. Dimension of B is also 5, 2. Then we can add them together. So A plus B. Okay, so this is also element-wise. Okay, so first number plus first number. 1 plus 2 equals 3. So last number plus last number. 10 plus 20 is 30. So this is element-wise. So let's look at A minus B. Okay, so A minus B. Same thing. So this is A is 1, B is 2. So 1 minus 2 is negative 1. So let's random look at 3, 2. So 3, 2. So it's A, and 3, 2 is A minus 16 is negative A. So we have negative A. This is also element-wise addition and elements-wise subtraction. And so let's look at multiplications. Okay, A and B. Okay, so let's look at the last one. So last one will be 10 times 20. So it's 200. Okay, so 2 times 1 equals, sorry, the first one times the first one from the second matrix is 2. So let's look at this number, A. So 2 times 4 equals 8. So this is element-wise multiplications. Okay, so let's look at A divided by B. Okay, so this is A divided by B. Okay, so let's A divided by B. Okay, so A, so this is first row, first column, divided by first row, first column. So 1 divided by 2 is 0.5. Okay, the last row and last column divided by last row, last column, that is 0.5. Okay, So we have addition, subtraction, element-wise multiplication, and element-wise division. Okay, it's always element for elements. The condition is the dimension of A and B should be the same. Okay, the dimension of A, so this is condition. The dimension of A and B should be the same with the same dimension.
Shutterstock Music.
Let's look at the two matrix multiplications. Okay, so let's use the same simple matrix. So x equals matrix 1 to 10 and 5 by 2. Okay, the matrix, the two matrix multiplication is simply the conditions. Okay, so this is m n by k, and also this is k by m. Eventually we have n by m. Okay, and suppose we have two matrices A and B. Okay, the first matrix, its dimension should be n by k, and so this is a dimension for the second matrix is k by m. So basic idea is the second dimension of the first matrix should be the same as the first matrix from the second. Sorry. Okay. The condition is we have matrix A, m by k, and matrix B, k by m. Okay. The second dimension from the first matrix should be same as the first dimension from the second matrix. Okay. Suppose for our case, 5 by 2, and we can 2 by 1, and that's fine. 5 by 2 and 2 by 1, the final result will be 5 by 1. Suppose we have 5 by 2 and 2 by 5, then we have 5 by 5. Okay, so the key is 2 should be same. Okay, and again, so this x is 2 by 5. Okay, so let's use the transpose. Transpose x will be 2 by 5. Okay, suppose let's y equals transpose x. We type x, we type y. Okay, so this is a dimension of x. So this is dimension of y. Okay, then the second dimension from x match the first dimension from y. So x times y. Okay, the condition. Okay, so let's get the z equals x percentage star and percentage y. So this is z value. Okay, so this is when we calculate, for example, this one 37. How can we get 37? So 37 is first row and the first column equals the first row from x times first column from y. So 1 times 1 plus 6 times 6. We have 37. Okay, so this is let me see. Okay, so this is x. Suppose I equals 1, j equals 1. So this is z, this one. So I equals 1, j equals 1. So the result will be x. So this is first, so this is I, and times y. So this is j. Okay, so this is it's 36. Okay, it's a summation. Sum. So this is 37. Okay, so actually it's I. So I colon, so 1 1. I colon. Okay, sorry, I have to. Okay, I'll make the X, Y, Z, and also this our function sum. I'm going to copy paste here. Okay, suppose let's choose another one. So 2 2. So 2 2. I equals 2 and J equals 2. Okay, the summation will be 53. See, so I is row. Okay, I is row. J is column. It's 53. Okay, so let's random choose another one. So this is 5 4. It's 5 4. Okay, so this is 5 and this is 4. Okay, so this is 5 4. Okay, so this is 5 and 4. We should get 110. So this is for X is 5th row times 4th column. Okay, so this is 5 times 4 is 20. 10 times 9 is 90. 20 plus 90 is 110. Is 110. And also we can use this one. So this is 110. So this is about 2 matrix multiplications. Topic number 3, a few examples. So we type .c10. I'm going to show you 3 examples. The first one is multiple equations. The second one is return estimation. And the last one is to calculate portfolio return. Okay, so .c10 21. Okay, and we have a multiple equation or linear equation. Okay, we have 3 unknown variables, x1, x2, and x3. So 3 times x1 plus 2 times x2 minus x3 equals 0, and 3 times x1 minus x2 plus x3 equals 1, and continue. So we have 3 equations, we have 3 unknown. Okay, so let's look at this one. Okay, and the first matrix, so A is a matrix. Okay, and A represent the coefficient. You see the 3, 2, negative 1. So 3, 2, negative 1, 3, negative 1, positive 1, the second row. The third row is negative 1, positive 4, and 0.5. So this is A. Okay. The B will coefficient 0, 1, negative 1. So this is B. Okay, so this is B. Will be this one. Okay. The solution will be X solve. Okay, so X solve. So X will be our solutions. Okay, so X will be a solution. Okay, so this is capital A. So this is A. So X, so dimension A is 3 by 3, and so length and X. So this is solution is 3 by 3. Okay, so if this 3 by 3 actually is 3 by 1. Okay, so let's is matrix X. Okay, it's not matrix. So let's use X2. Okay, so X2. So let's as matrix X, X2. So dimension X2. So minus dimension A. Remember we mentioned suppose A, so A percentage times percentage X2, then the result will be our 3 n times k times k times m is 3 by 1. Okay, it's actually 3 by 1. Okay, so let's look at our original one. So .c10 21. Okay, on the right hand side should be 0. You see this is very close to 0. And so second one is 1, and the last one is -1. So this is first application of matrix matrix manipulations. Example 2 is return estimation. So .c1022. So .c1022. Okay. The first thing is we download monthly IBM monthly data. Then we calculate how many rows. Then we assign initial value as now not available. Then we calculate return from number 2 to number A. And the basic idea is we assign P2. P2 is, so let's get this value first. Okay, we are going to use adjust closing to calculate return. Okay, the first return on February 1st, 1962 will be this value minus previous month's closing price divided by previous month's closing price. Okay, so this value minus this value, we add parentheses, divided by the second value. Alternatively is this month's adjusted closing price divided by the previous adjusted closing price minus 1. So we just use P2 divided by P1 minus 1. So let's copy and paste. So this is, we can use calculate return. Okay, add returns. Okay, and so we can manually, so this one divided by this value and minus 1, we'll get first return. You see, so this value is less than this value. So just let's do it. Okay, so I'm going to copy and divide by the first value and minus 1. Okay, so this match our first value. Yeah, so this is return. We can merge. You see, we can merge. And suppose this is we call y. We use data frame. So we need x and from 2 to n. Suppose we need the first column, and we need x. So let's use x date, and 2 to n. And also we need x dollar adjusted closing from 2 to n and plus return. Okay, we close it. So let's look at y. Okay, and so eventually we only we calculate return by using this adjust column. Okay, and after we finished, and we merge them with the first column as date. So as date, the second 1, 2, 3, 4, 5, 6 column adjust closing plus return. And we can, if we make it nicer, we can add column names. We add column name y. So the first one will be date. The second one will be adjust closing, and the last one will be return. Okay, so we can use we write a loop, we calculate return, and eventually we have the date, adjust closing, we have return column. Okay, so this is we use a loop. So actually, if we use a matrix, it's much easy. It's also one line. So let's look at return 2. So we use return 2 is simply x dollar signs, x dollar sign, x dollar. So this is adjust closing from 2 to n and divide by x dollar sign adjust closing 1, 2, and minus 1. n minus 1. Okay, so let's look at compare the difference between return and return 2. Okay, you see they are identical, 1 to first 4 numbers. Okay, and for this one, so this is a vector, and this is another vector. So we use it's called the element-wise division. So let's look at element-wise division. Is we use the n-1 value from adjust closing divide by n-1 value from adjust closing, and we shift by 1, then we get the same result. Okay, so this is much efficient compared with a loop. It's much code is much efficient. The last application is about portfolio return estimation. Okay, so this is example number 3, portfolio return. Okay. .c1023. Okay. Assume portfolio rate. This is the name of the R package, and if it's not available, then you can use install. Okay, let's see. It's available here. Okay. So I'm going to use this data set called S&P 500 return. Okay, I'm going to call it A. So let's look at make it simple. Okay, so let's look at dimension. And we have 1 year, 500 stocks return. Okay, 500 stock return. And because 500 is way too big, so let's look at ticker. And we have 1, 2, 3, 4, 5, 1, 2, 3, 6. Okay, so let's use a few stocks. Okay, so let's see. So use 1, 2, 3, 4, 5. Okay, we use 5 stocks. So we use a subset. Okay, so dimension of X is the head X. Okay, so these are all the return. Okay, all the return, and from 2013 January 2nd. If we use tail and tail, we use the tail X. Okay, I'm gonna use head X. So it's 5 tail X. Okay, so this is dimension of X. This is much smaller, 252 and times 5. Okay, suppose we can randomly pick up the weight. So weight equals weight, suppose 20% and 15%. 15%. Okay, I'm going to choose 4 value. Okay, I use W1 0.17, so this is weight equals WC W1 1 minus summation W1. Okay, so weight. Okay, so because we have 5 stocks. Okay, we can control 4 rate. Okay, 4 weight, 0.2, 20%, 15%, 70%, 11%. The rest will go to number 5. So this is a weight, and I use W1. W1 only have 4. Okay, so 1 minus summation. So rest. So we can just summation of W. This should be 100%. Okay, 100%. Okay, so W2, let's make it matrix. So matrix. So this, let's use matrix. So this is W. So W is a matrix. Okay, dimension of X, dimension of W2. Okay, you see the 252 times 5 and 5 times 1. Okay, and then, because how to calculate weight of each date. Okay, so basic idea is, so first row, so this is suppose IBM is 2%. Okay, 2%, 2.475%. So this number times 20%. The second return times second weight. Third return times third weight. Continue this way. Okay, so it is equivalent to, so actually it's portfolio return equivalent to X and star, the X percentage star, and times, so this is W2. Okay, W2 is a matrix. Yes, matrix. Okay, is matrix X. Okay, because X is not a matrix, so we have used X2 equal as matrix X. Okay, now we can use X2 times, so portfolio return will be X2 times W2. Okay, now we have our result. Okay, so this is head portfolio return. Okay, portfolio return. So this is date, this is portfolio return. Now we can use head X2, and we can use W2. I repeat, okay, how to calculate portfolio return. The portfolio return is this first row times first column. Okay, so first return times first weight plus second return times second weight plus third return times third weight, and continue this way. This is exactly the definition of matrix multiplication, a second meanings. Okay, second type. So we use the first portfolio is 252 days, and by 5 times the weight. Weight is 5 by 1. So our final result will be 252 by 1.
Shutterstock Music. Shutterstock Music.